this lesson, we'll look at how to simplify radicals and use a calculator to approximate radicals. How do square roots apply to oceanography? The speed, s, in knots of a wave can be estimated using the formula s equals 1.34 square root of L, where L is the length of a wave in feet. This is an example of an equation that contains a square root. Finding the square root of a number and squaring a number are inverse operations. To find the square root of a number n, you must find the number whose square is n. For example, 7 is the square root of 49 since 7 squared equals 49. Since negative 7 squared also equals 49, notice there's parentheses, so it's negative 7 times negative 7. Negative 7 is also a square root of 49. Bunny trail, this is a common mistake I see. When people type in negative 7 squared in the calculator, it gives you negative 49, which is correct use of order of operations. This is telling us square the 7, keep it negative. For any real numbers a and b, if a squared equals b, then a is the square root of b. Since 5 squared equals 25, 5 is the square root of 25. Since finding the square root of a number and squaring a number are inverse operations, it makes sense that the inverse of raising a number to the nth power is finding the nth root of a number. The table below shows the relationship between raising a number to a power and taking that root of a number. This pattern suggests the formal definition of an nth root. For any real numbers a and b and any positive integer n, if a to the n equals b, then a is the nth root of b. Since 2 to the 5th equals 32, 2 is a fifth root of 32. The symbol indicates an nth root. The n up here, which would normally be a number, is called the index. This is, of course, a radical sign, and the number underneath the radical sign is called the radicand. Some numbers have more than one real nth root. For example, 36 has square roots of 6 and negative 6. When there is more than one real root, the non-negative root is called the principal root. When no index is given, as in square root of 36, the radical sign indicates the principal square root. The symbol stands for the principal nth root of b. If n is odd and b is negative, then there will be no non-negative root. In this case, the principal root is negative. So we know square root of 16 is 4, the principal square root. Negative square root of 16, so they want the opposite of the principal square root of 16. Plus or minus indicates both square roots of 16. The cube root of negative 125, they want the principal cube root of 125. Negative fourth root of 81 is negative 3, so they want the opposite of the principal fourth root of 81. So if we have an even index, we will get one positive root, one negative root. Or if b is negative, we're not going to get any real roots because we can't have a number times itself that's a negative. If it's odd, then we're going to get one positive root, no negative roots. And if the number under the radical sign, the radicand, is negative, we'll just get one negative. So we can multiply a negative times itself an odd number and get a negative, and a positive times itself an odd number and get a positive. If b equals 0, well, it doesn't really matter because 0 times itself however many times is always 0. And it's about time we started doing some problems. Directions are simple. Simplify. The square root of 16 is 4. The square root of x to the 6 is x cubed. X cubed times x cubed would be x to the 6. And the original problem had a plus or minus in front of it, so does our answer. Our original problem has a negative in front of it, so will our answer. The square root of something raised to the 4th power, we're going to end up just dividing that exponent by 2, and we're done. If you don't know the 5th root of 243 off the top of your head, you can type it in your calculator. On the multi-view calculators, we type 5, and then the button that's above the caret symbol, which is the x root, and then type in 243, hit enter, and lo and behold, it's 3. So when we are taking the root of things raised to the power, we're just dividing by that index. So 10 divided by 5 is 2, and 15 divided by 5 is 3. Okay, the rules will change, but at this point, the square root of -4, all we know about is real numbers today. So the answer for today is not real. There's a name for numbers that aren't real, but we don't know them yet. When you find the nth root of an even power and the result is an odd power, you must take the absolute value of the result to ensure the answer is non-negative. So the square root of, we know, -5 squared, square root and square root inverse operations, it's, well, absolute value of 5, because -5 times -5 would have been 25. Okay. Square root of -2 to the 6th is, okay, -2 cubed is going to be -8, but then the absolute value of that is 8. If the result is an even power, or you find the nth root of an odd power, there is no need to take the absolute value. Why? Okay, 6th root and 6thing are inverse operations. So the obvious answer is just t, but we started off with an even exponent, so we're going to have to put absolute value bars around it to preserve its positiveness. Note that t is a 6th root of t to the 6th. The index is even, so the principal root is non-negative. Since t could be negative, we must take the absolute value of t to identify the principal root. The 5th root of 243 is 3, and 15 divided by 5 is also 3. We started off odd, ended up odd, everything's odd. So since the index is odd, we don't have to worry about the absolute value on this one. Recall that real numbers that cannot be expressed as terminating or repeating decimals are irrational numbers. Square root of 2 and square root of 3 are examples of irrational numbers. Decimal approximations for irrational numbers are often used in application. The time t in seconds that it takes a pendulum to make a complete swing back and forth is given by the formula t equals 2 pi times the square root of L over G, where L is the length of the pendulum in feet and G is the acceleration due to gravity, 32 feet per second squared. Find the value of t for a 1.5 foot long pendulum. Okay, half formula can use. So t equals 2 pi times the square root of, they said L was 1.5. So we can plug and chug the 1.5 in for L and the 32 in for G and type that into the calculator. And I get t is about, they didn't say what to round to. I'm going to go 1.36, hundredths place is a good rounding point, seconds. So if we have an even index and our radicand is positive, we'll get one positive and one negative root, but if it's negative, we don't get any. If it's odd, then we get one positive root, no negatives for positive in radicand, and no positive, one negative if our radicand is negative. Of course, if b is 0, there will be one real root, and it is 0.